Welcome viewers, in this video we will see the incompletely specified function don't care term in the Karnaugh map K-map. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic don't care condition. Unspecified functions don't care term in the Karnaugh map. In some logic circuit, certain input conditions never occur. Therefore, the corresponding output never appear. Right. So, while designing the logic circuit, some combination is not occurred in the designing. While designing is not occurred. In such cases, the output level is not defined. It can be either high or low. Right, the corresponding terms are not defined. It may be 0 or 1. That will not affect the output of the logic circuit. Right, it may be either 0 or it may be either 1. So those output level are indicated by X or D, don't care condition, or it is indicated by X in the truth table, and are called don't care outputs or don't care conditions or incompletely specified function. Right. So while designing the logic circuit, certain inputs are not specified. It may be high or low. That will not affect the circuit design. That will not affect the circuit output. Such cases, such the functions are marked as either X or D. That is called X means it may be either 0 or 1. D indicates don't care condition. Right. So these are all the terms are called don't care output or don't care condition or incompletely specified function. Right. Now we'll see one truth table so that we are able to understand clearly. So here the three inputs are available A, B, C. The output is Y. Because of three inputs 2 to the power 3, there are 8 combinations are available. Right. 0, 0, 0, 0, 0, 1 from 1, 0, 1 up to 1, 1, 1. For the first 6 outputs, for the first 6 combination, the output is given. Right. For 0, 0, 0, it is 0. 0, 0, 1, it is output is 1. 0, 1, 0, 0. 0, 1, 1, 1. 1, 0, 0, 0. 1, 0, 1, 1. But for the 7th output, 1, 1, 0, it is not given. Similarly, 1, 1, 1 also not given. It may be either 0 or 1, so that it is indicated by X. Right. So the 3 inputs are available. Due to 3 inputs, there are 8 combinations are available. In that first 6 combination, the outputs are given either 0 or 1, clearly given. For the last 2 outputs, last 2 combination, the output is not given. That will not affect the output of the logic circuit. These 2 inputs, these 2 combination will not affect the output of the logic function. So it is not specified. So that can be marked as X. So these 2 are all called a don't care condition. Now we'll see how it will affect the drawing the K-map. Right. So first 6 combination having the specified output, last 2 combination not having any output. So there that is taken as a don't care conditions. Right. As shown in the table, truth table, the output from 0, 0, 0 to 1, 0, 1 are defined. That is first 6 outputs are clearly defined. For remaining 2 conditions of input, the output is not defined. For the remaining 2, the output is not defined. Hence, these are all called don't care condition of this truth table. Right. The first 6 having the specified output, last 2 remaining 2 having not defined. So that it is called a don't care condition in the table. Right. So what we need to do while plotting the K-map or while going for the circuit design, a circuit designer is free to make the output for any don't care condition either 0 or 1 in order to produce the simplest output expression. Right. So that circuit designer can take this don't care condition either 0 or 1 according to the requirement he can take. Right. So while designing, we can take the don't care condition as either 0 or 1. Right. So how to make the expression? So f of ABC equal to sum of min term 1, 3, 5. For this only the output is high. For other outputs, for other combination, the output is 0. So that only 1, 3, 5 having high output. Right. The last two terms 6, 7 is not defined, so that is given as D, don't care condition. Don't care condition 6 and 7, right? So totally how many terms available? 1, 2, 3. 3 term having high level, this last two term having don't care condition. That is the 5 terms are available. Now we'll refer the two table. See this 1, 3 and 5 having the level high level. The 0, 2, 4 not having 0 level. So it is not given in the final expression, not given in the Boolean expression, right? So 1, 3, 5 is given. F of ABC equal to sum of min term 1, 3, 5 and 6, 7 as a don't care condition. So totally we have 5 terms are available. So this 1, 3, 5 as a high level, 6, 7. So while we need to plot the K-map for these 5 terms, these 3 are the having high output, 6 and 7 is a don't care condition. It is marked as either D or X, right? After plotting the K-map, while grouping the cell, while we need to group the cell, either we need to group with 8 cell or 4 cell or 2 cell, or finally not possible means isolated 1 cell is there, right? So while grouping we can take this don't care condition 6 and 7, right? We can, if it is needed, we can, while grouping the cell, we can take it into account of this 6 and 7, right? But it is not necessary to group all the don't care condition. If possible, we can group with this ones, right? Otherwise we can leave it, right? So the don't care condition will be useful while grouping the cell. If it is possible, we can group the don't care condition, right? If it is not possible, we can leave it. It's not necessary to group all the don't care condition. If yes, if it is required while grouping, we can take it into account, right? So in this video, we discuss about what is the don't care condition, how to deal with this don't care condition in the designing of K-map, right? Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.